Here are solutions to homework set number 2 for ECE 476-676 Advanced Embedded Systems. This homework set looks at using loops, if statements, and subroutines in Python. Now the first problem is repeat from homework set number 1 using subroutines. Add resistors in series and parallel and use those subroutines to compute the total resistance. So in series, resistors add. In parallel, they add as the sum of the inverses inverted. Then using those subroutines, I can combine these. 300 and 400 in series, call that RA. Take that in parallel with 700, that's RB. RC is 200 in parallel with 600. D is RC plus RB in series. In parallel with 500, in series with 100. The net result is, if you run that code, 350 ohms. Now in Python, when you do that, once I run the code, the program ends, but series and parallel are now in memory. I can call those routines. I can say what is the series resistance, 400 and 500 ohms. What is the parallel resistance, 400 and 500 ohms. That works for complex numbers too. I've got series and parallel, just like before. Take 60 in parallel with minus J80, plus J50 in parallel with 70. Put those in series with 40, in parallel with 90 minus J110, in series with 30. And I get the same answer we got in homework set number 1, 92 plus J8. And note that Python works with complex numbers just as well as real numbers. So it is the series resistance of 100 and 200J. It's 100 plus 200J. What's the parallel impedance of 100 ohms and 200J ohms? 80 plus J40. You can also say 100 plus J30 plus 30J, the syntax right. 200 minus J200. Problem 3. This looks at for loops. Suppose player A rolls 5 12-sided dice, B rolls 3 20-sided dice. What's the chance that A is going to have a higher total? So what I'll do is I'll do some loops. Starting from 0 points, I will repeat 5 times, roll 5 12-sided dice, that's A, roll 3 20-sided dice for B. If A is bigger than B, A wins, ties, and loses. If I repeat that 5 times, just to check it, here's the first roll. A got 27 to 42, lost. 30 to 31, lost. 48 to 13, won. 12 to 22, lost. 26 to 37, lost. Okay, seems to work. Now repeat 100,000 times. So put that in a loop from 0 to 100,000 games. Play a 5-game match. So here I play a single game, win, tie, or lose. After 5 games, I'll check. If I won more than I lost, I won the match. Tied, lost the match. That's for single match. Repeat 100,000 times. When I'm done, 10,000 times. Here's the wins, losses, and ties. So 47% chance of a win, 5% chance of a tie, 47% chance of a loss. Let's see. While loop. If instead of playing a fixed number of games like a 5-game match, keep playing until somebody is up by 3 games. So if this is a single game, I'm going to roll 5 12-sided dice, 3 6-sided, 3 20-sided dice. Check to see if I won, tied, or lost. Keep going until somebody is up by 3 games. If at the end of the match I'm up 3 games, I won. Can't tie. Down 3 games, I lost. If I repeat 10,000 times, then A wins 5,000 times, loses 4,900, so roughly 59% chance of a win, 49% chance of a loss. That is homework set number 2 for 476. Basically, if statements, while loops, for loops. For loops execute a fixed number of times. While loops keep on going until a condition is met. And there's if statements. Note also indentation is important. In Python, indentation tells you what's part of the loop. When I break the indent, that's the end of the loop. So unlike C, unlike MATLAB, indents are all important in Python. There are no end statements. The end statement is when you break the indentation. So that's homework set number 2 for 476. Looping in Python.